In this lesson, you will be able to 1. Illustrate quadratic equations, and 2. Solve quadratic equations by extracting square roots and factoring. In this part, let us define a quadratic equation in one variable. It is an equation of degree of 2, and its standard form is a x squared plus bx plus c equals 0, where a, b, and c are real numbers, but a is not equal to 0, and x is the variable. Quadratic equations may be written in various forms. As you notice, a quadratic equation is an equation in which the highest power of the variable is 2. Now as we move on, working with a quadratic is usually simplified when the quadratic equation is written in standard form. A x squared plus bx plus c equals 0. For the first example, we will write each quadratic equation in standard form and determine a, b, and c. Given the first equation, 5x squared plus 3x equals 7. To be able to make it a standard form, you have to subtract -7 from both sides to eliminate 7 in the right-hand side of our equation. Finally, we have 5x squared plus 3x minus 7 equals 0, where a is equal to 5, b is 3, and c equals -7. There you have it. Now let's proceed to the next example. Given the 2x squared equals -8x, how do we write it into standard form? As you can see, the given is the first term, 2x squared. We can just write it down here. The next thing that we need to do is to eliminate -8x on the right-hand side of our equation. For us to do that, we will add 8x both sides. There you have it. We have the first term, 2x squared plus 8x. Good to go, but there is missing, right? We don't have the constant term, but still we can identify a, which is 2, b equals 8, and c. Since it is missing, then it became 0. Did you get it? Now it would be great if we could try your skills in the following given here. Try the following and write quadratic equation in standard form and determine a, b, and c. You can pause this video and try writing the following example given in the first part of our lesson and try answering these questions. Once done, do not forget to verify your answer to your teacher. You know what? There are several ways to solve quadratic equations. The first one is by extracting the square root. The second would be factoring. Third, you can also visualize the quadratic equation by graphing. You can also use Desmos or GeoGebra to visualize it, or we could do it manually. The fourth method would be completing the square. And finally, the most convenient one, the use of quadratic formula. And now, we will be diving into the first method, solving quadratic equations by extracting square roots. I suggest you familiarize yourself to this important rule or principle governing this method. The square root principle. This rule is basically saying that if x squared is equal to a and a is greater than or equal to 0, then there are two possible answers, or I should say roots in other term. It will become x equals square root of a, or x equals the negative square root of a. As you can see, the possible answers can be positive or negative of a square root of the given constant. For example, if x squared is equal to 25, then identifying the a, which is 25 in this case. Using the square root principle, then we have x equals plus or minus the square root of 25. Simplifying this will give us plus or minus 5. As E further discuss, the square root principle is useful in solving quadratic equations of the form x squared equals c, when c is not a perfect square and c is real. For our next sets of example, we need to solve quadratic equations by extracting square roots. Let us solve for x for the first given x squared equals 49. Applying the rule for square root principle will make our lives easier here. We write x equals plus or minus square root of c, which is 49 in this case. Then we have to simplify the radical. Since 49 is a perfect square number, it will be easy for us. Square root of 49 is 7. Finally, we have x equals plus or minus 7. You can also use the term positive or -7 as well, if you insist. Therefore, the two solutions are +7 and -7. There you have it. Moving on to the next example, given m squared plus 3 equals 51. Now what? This one is a bit different, but we can just subtract 3 from both sides to eliminate 3 from the left-hand side of our equation, leaving us m squared equals 48. As you can see, we can now apply the square root principle. Then it would become m equals plus or minus square root of 48. As you can see, 48 is not a perfect square, right? So the thing we need to do here is to factor the radicand. Can you find the two numbers if we multiply them will give us 48? Take a moment to pause this video and think about it. There you have it. The two factors are 16 and 3. As we continue, we write m equals plus or minus square root of 16 times 3. We know we can simplify this one, right? The thing that we can do here is to simplify the radicand. Then we have square root of 16 is 4. Then we write 4 outside the radical symbol. Square of 3 is just the same. Why? Because 3 is not a perfect square number. So it will remain. There you go. After following right process, we have the final solution of m equals plus or minus 4 square root of 3. If you come this far, you are doing great. Let us try the third given example. 4x squared minus 9 equals 71. The thing is, we need to eliminate the negative 9 on the left-hand side by adding 9 to both sides. This will left us 4x squared equals 80. As you can see, we can isolate the x here. By dividing both sides by 4, now we can have x squared equals 20. Now we can apply the square root principle, and this will left us x equals plus or minus the square root of c, or constant, which is 20. Since 20 is not a perfect square number, we can factor the radicand. We can use the product of 4 and 5, right? So we write x equals plus or minus square root of 4 times 5. Then, finally, as we simplify the radical, square root of 4 will give us 2 outside the radical symbol. Square root of 5 will remain. So our final solution are x equals plus or minus 2 square root of 5. Alright, let's have our final example before the activity. In this case, we have 5x minus 3 quantity squared equals negative 32. How can we solve this? First is to apply immediately the square root principle, since the two terms are bounded by square. Using it gives us 5x minus 3 on the left-hand side equals plus or minus square root of negative 32. The fact that there is still 3 on the left-hand side, we have to add 3 both sides to eliminate it. After doing it, the remaining would be 5x equals plus or minus square root of negative 32 plus 3. We have to isolate x here, so we divide 5 both sides, giving us x equals plus or minus square root of negative 32 plus 3 all over 5. We know that there is a factor of negative 32 that has a perfect square number. It can be positive. Can you guess that? Take a moment to pause this lesson to think about it. Very good. We can use 16 and negative 2. Then as write our next process, we have x equals plus or minus 4 square root of negative 2 plus 3 all over 5. What can we notice here is the fact that there is a negative number. We all know that this number is not a real number. Therefore, if you encounter this one, therefore we can conclude that there is no real number solution to the given equation. You've completed the first 4 examples for extracting square root for quadratic equation. Now it's your turn. Practice makes progress. You could try the following given to solve for x. Take a moment to pause and review the previous example, and write all the necessary process to your notebook for your reference. And now, we can proceed to the next part of our lesson. The second way of solving quadratic equations, and it is by factoring. You know what? We have procedure in solving quadratic equations by factoring. Following these steps will guide you along the way. Step number 1. You can transpose all terms on the left side of the equation if necessary. You have to clear the equation of all fractions if necessary, then transpose. Also, it is important to remove parentheses, then transpose. Step number 2. You can combine similar terms. The next step would be factor the left side of the equation, then equate each factor to 0. For step number 5, solve the equation in step 4. And for our final step, check each root by substituting it in the original equation. Please take note of these steps. Some quadratic equation may be solved by factoring and by using the new principle that I will show you. And that is the principle of zero property products. Following this rule, if a times b is equal to 0, then either a equals 0 or b equals 0, or both a and b are 0. For us to apply the rule, let's have the following examples. Let us solve each quadratic equation. The first one would be x squared minus 7x equals 0. Since our method is factoring, we have to factor the given quadratic equation. The way we do that is to get the common factor of the left side of our equation. Can you see the common factor? That's right. We have x, we factor out the x, and we have the quantity of x minus 7 equals 0. When we equate each factor to 0, it means the two possible solution would be x equals 0 or x minus 7 equals 0. Now to handle this second solution, we have to add 7 both sides, right? Finally, we have x equals 7. How can we verify if our answer is correct? Let us check our answer. If x is equal to 0, we have to use the original equation and plug in the 0 to the x variable. Doing it, we have 0 squared minus 7 times 0 equals 0. If we get to continue that, we all know that the answer both sides will be balanced, and that is equal to 0. This will prove that the first solution is correct. Next, if x equals 7, we have 7 squared minus 7 times 7 equals 0. 7 squared is 49, right? Also 7 times 7 is 49 as well. Then 49 minus 49 gives us 0. Finally, 0 equals 0. The solutions to the equation x squared minus 7x equals 0 are 0 and 7. Now if you get that process, you are great. For our second example would be 25x squared plus 10x plus 1 equals 0. I'm going to share to you a problem-solving tip to do this particular problem. Remember this pattern: the factors of a perfect square trinomial is a square of a binomial. X squared plus 2xy plus y squared equals the x plus y quantity squared. I suggest that you're right and even memorize it, because that would be helpful for the problem like this. Going back, we can use the pattern earlier. Since the given equation is classified as perfect square trinomial, we can factor it to make it as 5x plus 1 quantity square equals 0. Expanding the binomial here, we have 5x plus 1 times 5x plus 1 equals 0. Then, we equate each factor to 0. It will be 5x plus 1 equals 0, or 5x plus 1 equals 0. Solving the roots we have 5x equals to negative 1. Finally, isolating x, we have x equals negative 1 over 5. There you have it. As we continue our third example, we have the given 18x squared minus 39x equals 15. First, we have to subtract 15 from both sides, and it will become 18x squared minus 39x minus 15 equals 0. If there is a possibility that we can reduce the three terms, we can do that as well. Let's try to divide the equation by 3. If the answer is whole number, there we don't have problem with that. Doing it, we left 6x squared minus 13x minus 5 equals 0. At this point, it is easy for us to factor that, right? We find the two factors. 3x plus 1 times 2x minus 5 equals 0. Finally, we can equate each factor to 0, giving on the left side we have 3x plus 1 equals 0. On the right side we have 2x minus 5 equals 0. Let us solve the left side. We have to eliminate 1 on the left side of the equation by subtracting negative 1 both sides. Then we have 3x equals negative 1. As we continue, we isolate x on the left side of the equation by dividing 3 both sides. Then we have x equals negative 1 over 3. Now we have to solve for the other roots. We have to eliminate negative 5 by adding 5 to both sides of the equation, leaving us 2x equals 5. We isolate x by dividing 2 both sides. That will give us x equals 5 over 2. That's it. Now that you have already know the process of doing it, you can practice and try it your skills now. Try to solve each quadratic equation. Please feel free to pause this lesson and think about the process and the steps of doing it. Write your answer to your notebook and verify it to your teacher. These two part of our lesson is just a basic examples. As we proceed to the next part of our lesson, we can encounter quadratic equation that is not written in the standard form. ax squared plus bx plus c equals 0. See you in the next part of our lesson. Quick one. As you learn this lesson, can you write in the comment sections the important thing or process you've learned in our discussion? I'll appreciate you.